Hi class, this is Ms. Cook. In this example, we are going to use the law of sines to solve a side-side angle triangle with two solutions. So we have a triangle here that has angle A of 40 degrees, side A with 54, and then side B is 62. All right, I don't know what the units are. That's okay. So here we're going to, since I know this one has two solutions, I'm not going to worry with the picture, but I am just going to jump straight into using the law of sines. So just like previously, we are going to use the two given pieces of information for angle A. So that ratio for the law of sines says that side A of 54 divided by the sine of angle A, which is the sine of 40 degrees, should equal, now once again, I'm not given any information about side C or angle C, so I'm going to have to use side B, okay, to try and start off by solving for angle B. All right, so B is 62, and then I will divide that by sine of B, and we're going to try to solve for angle B. So once again, we can cross multiply and divide. I did this 2 videos ago if you need to go back and see how I did that. To get that sine B is equal to 62 sine of 40 degrees divided by 54. Okay? So then we can come to our calculator here. All right, so 62 sine of 40 divided by 54. All right, so I get 0.738. Oh, I changed. All right, so I get 0.738. Okay. So now I use an inverse sine function in order to solve for the angle B. So B, and I know this has two solutions, so I'm going to call this B1 equals sine inverse of 0.738. Okay. So I hit second and then sine to get the sine inverse function in my calculator, and then 0.738. I know you can't see the whole calculator here. I'm trying to squeeze it all into my screen. So my angle B for quadrant 1 is going to be 47.56. Okay. So that is 47.56 degrees. Now again, sine is positive in both quadrant 1 and quadrant 2, and I could have an angle theoretically for sine B, or for angle B, that lives in quadrant 2, since quadrant 2 does not quite reach it only stops at 180 degrees. So to find that quadrant 2 angle, angle B2 is going to be 180 degrees minus my B1, which is 47.56 degrees. Okay. Minus 47.56 degrees. All right, and I get 132.44 degrees. Okay? So we need to verify. So if you didn't know that this was two solutions, you could then quickly verify that this angle does indeed work. So I need to check, is angle A plus angle B2 greater than 180? Okay? So 132 plus 44, well, A plus B2 is only 172.44 degrees. So no, it's not quite 180 degrees. All right, So both of these angles for angle B are good to go. All right, so on this page, we are going to continue with triangle 1. Okay, and then I have a blank slide on the next page, and we'll solve for triangle 2. All right, so triangle 1, we want to find angle C. So we are going to say angle C is 180 minus angle A, which is 40 degrees, minus angle B1, which is 47.56 degrees. Okay. So I get 180 minus 40 minus 47.56. So angle C for triangle 1 is 92.44 degrees. And we can call that C1 if we want to, 92.44 degrees. Okay? So now all that's left is to find side C1. Okay? And in order to do that, we are going to use the same process as we've done all along in this chapter, where we are going to use the law of sines. So I'm going to choose to use side A and angle A to set this up, because once again, those are the things I'm given. I don't want to make a guess with side B and angle B. You could use that if you want, but you may be off just a little bit. So just to be safe, I'm going to use side A and angle A. So A is 54 degrees divided by sine of angle A, which is 40 degrees. And then that equals to side C divided by the sine of C1, which is 92.44 degrees. So that means little c1, we can call that little c1. So that means little c1 equals 54 times sine of 92.44 degrees divided by sine of 40 degrees. Okay? All right, so that's 54 sine of 92.44 divided by sine of 40. All right, and I get 83.93. 83.93. And that makes sense because that's the biggest side, which is also opposite the biggest angle, which is an obtuse angle, since it's greater than 90 degrees. All right, so that is triangle 1. On the next slide, we're going to do the same thing, but replace anything that has B1 in it with B2. And we can do this process again to find our second triangle. All right, so now I have here all the information I need to solve for my second triangle. So I already have found angle B2, which is our quadrant 2 angle, and then we're given side A, angle A, and side B. So let's start with finding C2, or angle C2. So just like before, we are going to say that C2, that missing angle, is 180 minus the other two angles that we know. So minus 40 degrees for angle A, and then minus 132.44 degrees for angle B2. So I can just type that into my calculator and see what I get. All right, so it is a very small angle. That's okay. Our angle C2 is 7.56 degrees. Okay, so now I can use the law of sines, in order to solve for side C2. Okay, so I am again going to use angle A and side A since those are the two things I'm given in the problem. I'm sort of taking a chance that I have solved for B and everything else correctly. So I'm just going to use what I'm given. And once again, that ratio is going to be side A, which is 54, divided by the sine of angle A, which is 40 degrees, and that equals C2 divided by the sine of angle C2, which is 7.56 degrees. All right, so to solve that, just like we have, we're going to multiply sine of 7.56 degrees to both sides. So I get C2, side C2 equals 54 times sine of 7.56 degrees divided by sine of 40 degrees. All right, so one last visit to the calculator. 54 sine of 7.56 and then divided by sine of 40. And I get 11.05. So side C2 is 11.05. All right, and there is our triangle 2. Have a great day.